Hello, my name is Jagdish Marani. I'm from Pivotal Product Marketing, and welcome to our webinar on domain-driven design and reactive programming. We were fortunate today to get some subject matter experts to discuss this topic, and given the number of people that have signed up, this is obviously a very popular topic. So what I'd like to do is basically give you a little bit of a bio on the speakers, and then let them address the topic. So our speakers today are Vaughn Vernon and Wes Williams. Vaughn is a veteran software craftsman with more than 25 years of experience in software design, development, and architecture. He is a thought leader in simplifying software design and implementation using modern and innovative methods. Vaughn is a prolific author in the areas of domain-driven design and reactive programming, and we'll have some pointers to his books for you during the webinar. Wes Williams is a hands-on software developer and architect with extensive experience in delivering world-class systems across a variety of industries. Wes is a practitioner of modern design patterns like domain-driven design and reactive programming, and he will cover how in-memory grids like open source Apache Geode and Pivotal's GemFire product, which is based on Geode, fit within these modern concepts. Wes is a contributor to Vaughn's book on implementing domain-driven design, and the two have collaborated before. So they're a natural pairing for this webinar. So I'm very pleased to have these two thought leaders with us today. So let's get on with it, and let me turn it over to Vaughn Vernon.
Well, first of all, I'd like to thank Pivotal, all the fine people there, for inviting me to share in this webinar event. And just wanted to give you a little overview of the books that I've had published. And I'm the author of Implementing Domain-Driven Design, which is a detailed, exhaustive coverage of domain-driven design and its implementation. Also, about a year ago, I had Reactive Messaging Patterns with the Actor model published. And my most recent book was released around June 1st of this year, Domain-Driven Design Distilled. And you're welcome to follow me on Twitter if you'd like to keep up with my latest work. So a good place to start for this event is to ask the question, what causes software projects to lack well-designed domains? And while there are probably a lot of reasons for this, I was wanting to focus on just a few. These are ones that I see a lot in my training and consulting work. One of those is having a data-only focus when developers should really aim higher to capitalize on the unique business drivers of the project. And what I mean by this is that sometimes developers are so focused on data and even the database that they have a difficult time even referring to the domain model or business concepts when having conversations about the project on which they work. They'll often refer to a project in terms of the database. They will refer to it as Oracle or MySQL or Postgres or MongoDB or Cassandra, instead of referring to the more significant drivers of the project, which is the terms used by the business and adhering to the vision of the actual project that's funding the effort that the developers are involved in. So I think that developers should really aim higher and be more focused on the business, and this will prevent efforts from turning into a data-centric approach that leads to anemic domain model, anemic entities where, again, data is the focus, and for all practical purposes, the domain model just becomes a way to cart data back and forth from the database to the application to the database. So this is a lot of the problem that I see, and how can we go about solving that? Well, I think that the answer to a lot of these issues is domain-driven design, but let me introduce you to domain-driven design by making this long story a bit longer. Here's how I see the modeling efforts go bad a lot of times. We start out with a simple model, and here I'm introducing a Scrum project management tool and the model for that tool. And if you're familiar with Scrum, you know that a Scrum product is the software that's being developed. You know what a backlog item is, what the product backlog is, and you're familiar with releases and sprints. Backlog items have tasks, and tasks have estimation log entries, and releases have scheduled backlog items, and sprints have committed backlog items. So this is the basic model around a Scrum execution framework tool that helps a team in their efforts to develop software. But what happens from this initial model? Oftentimes we see teams reason that, well, we're supporting multi-tenancy. We're going to have multiple subscribers to this service, and therefore we want each subscriber to be represented as a tenant, and then users within the tenancy will have accounts, and users will have permissions to do things. So let's add this to the model. Further, the team says, well, we also want to support threaded discussions, and discussions aren't complete without being part of a forum, and we need to support posts within a discussion for individuals to post their comments about the discussion. And we also have things like milestones and target dates and so forth, so we need to support calendars and calendar entries. This leads to even more ideas about how the model should support accounts, such as being able to pay for their subscriptions, and support plans, where support plans have incidences that are reported and then covered by the support team. You see where this is leading? We even add more concepts. We have the idea of a team that is practicing within Scrum. We have product owner and team members within a team, but how are we going to allocate available time for each of the members of the team? Well, perhaps we need to introduce resource management into this project, and we're going to manage resources through time-consuming resource concepts, and each of those time-consuming resources will have schedules and availability, and that way we can track each of the team members, their availability, and how much time they have to spend on this project, and if they have any time that can be provided on other projects. And then, of course, calendars and calendar entries are going to be actually modeled as reminders, milestones, target dates, retrospective, and planning meetings. And before long, this model has grown out of hand, actually. We have many other concepts that we need to support those basic ideas, And in effect, our entities have grown in number to the point where very few people can actually understand the core parts of the model. What is the business actually interested in for this specific model? This leads to what is often called a big ball of mud. So what can we possibly do about this situation? If we aren't careful, the team is going to be so blinded by the data and the data model around this problem space that they're going to miss the forest for the trees, so to speak. They'll completely lack core business knowledge, and they'll fail to collaborate with one another in terms of the business, as they're really just data focused. So how do we actually create a good domain model? How does a good domain model help in reducing complexity? In fact, how do we avoid the big ball of mud? Well, we have to invest in business knowledge, where domain experts and developers work together to form a cohesive, tight-knit team, and this team is going to drive out the real business concerns and address the true vision of the business in terms of not only data, but more importantly, business process and behavior. So when we put business experts and developers together, we're actually investing in knowledge workers, we're investing in the business, and we are developing business value. We're able to do that by unifying the mental models of both domain experts and developers, who are each focused on their own concerns. The business experts obviously around the business and how to be successful in business, whereas developers are generally focused on technology, programming languages, and the like. But when we put these two groups of individuals together, they help to refine each other's thinking processes and refine their business understanding to the point where it becomes a significant business investment in the knowledge workers that are involved in the project. So this leads to a feedback loop between this team, and they're able to develop a language around the domain or the business process that they're working within. Notice that while each probably has a vision of the software, once they begin conversing with one another and collaborating, there are question marks in the mind of each kind of participant in this feedback loop. That's because questions are asked where one lacks knowledge in a certain area of expertise, and this is far from a command and control environment. It's actually very collaborative, and this is where deep learning comes in on the part of the team members. And it results in very good business insights, and it's where the aha moments occur. So the effort of these team members is to develop a specific domain language as a well-defined software model. And one of the primary tools that they're going to use to do that is what domain-driven design refers to as a bounded context. This is a contextual boundary, a semantic boundary, where a ubiquitous language is spoken by the team and where the language is developed as a domain model. The domain model reflects the spoken language, the mental model of the team, and when reading the source code of the resulting model, we actually see a very close resemblance in the software to the conversations that business experts and developers have. Inside this model, we expect, or inside this bounded context, we expect the model to be consistent in the meanings of the terms, phrases, and expressions that we use when we describe things about the specific business problem domain. We also expect that anything outside this boundary does not have to adhere to the ubiquitous language definitions that we've established as a team. That's because they are not in this context. They're not within the bounded context. So the bounded context forces us to examine what is core, what belongs in this ubiquitous language, what is part of the language, what is within context, and what is not in context. So we're going to use the strategic design tool called bounded context to help us examine what is in context and, for that matter, to understand also what is out of context. Outside the boundary, other concepts will not adhere to the contextual model that's inside our core bounded context. So using these principles that I just introduced, we can challenge the tangle that was produced in this big ball of mud and try to find the core language of our domain model. So let's go through each of the additions that we made to the original model and apply a challenge regarding the ubiquitous language. Do these elements adhere to the language of Scrum? If they don't, then they don't belong in this model. They're out of context. Certainly tenant, user, and permission are very important concepts that are necessary for the overall system to work. We do need to support multi-tenancy, and each tenant must have a select group of invited users to participate in the work on Scrum projects. And each of those users need to fulfill roles, and thus they have permission. But still, each of these concepts do not belong to the language of Scrum. They don't adhere to the language of Scrum. Therefore, we're going to say that these are out of context. On the other hand, while we're not going to bring tenants and users and permissions into this model, we still do need actual users. The users on this model, of this software, are product owners and team members. These are actually derived from users who play roles. And we'll talk about that more in a moment, but by deriving users and roles, we can determine who the product owners and team members are within the team that are working on a Scrum project. These are definitely in context. They're part of the core model. On the other hand, what about account, support plans, payments, and incidences? These are very important. We certainly need to support our users, and we have to get paid for what we're doing, or we'll go out of business. But these have nothing to do at all with the language of Scrum. Therefore, these are also out of context. They're not part of our core domain. The same goes for resource manager, time-consuming resource, schedule, and availability. We probably do want to have concepts like this somewhere in our system, but they're not part of the core model. So we're going to reject them, and they will not be part of our core domain. On the other hand, when a team member says that they will cover working on a task, they become a volunteer for the task. Therefore, we're going to model a volunteer, which conceptually is a team member that is participating in the project working on a task. Calendars and calendar entries are not within our core domain model. However, reminder, milestone, target date, retrospective, and planning likely could be part of our model, but for now, they're out of scope. They're not part of this sprint. We'll consider them for a later sprint, but right now, we're going to focus on the core model that we've already discovered. We will also support threaded discussions. We can have discussions for team members and product owners about their product backlog item releases and sprints, perhaps even tasks. However, we won't bring forums and posts into this model, but we will still have a concept of discussion that will be associated with each of the relevant modeling concepts. So what do we actually end up with? We end up with a core domain model that is focused on the ubiquitous language of Scrum. This is a rather small model. It's easy to reason about. The team can have productive conversations and collaborate around this model, developing tests and scenarios that test the software and challenge the assumptions about the model and help us to do the best job that is possible in sticking with the business's main focus. And what do we find from the other model concepts that were out of scope, out of context for the core domain? These most likely belong in their own bounded context. They're part of another ubiquitous language or other ubiquitous languages. And so with any domain-driven design project, we will have multiple bounded contexts. And as you can well imagine, these bounded contexts also help us to achieve microservices, and bounded contexts make very good microservices. So what is reactive software, and how does it help developers solve complex applications and integration problems? Well, let me address this question now. Let's start out by referring back to the multiple bounded contexts that exist in this project. Obviously, if we're going to have, for example, tenants, users, and roles, in order to derive our product owners and team members in the core bounded context, we're going to have to integrate with the bounded context that has users and roles. How will we do that? We can use reactive programming. Let's see how. Inside a bounded context, we have concepts such as backlog item. Backlog item is an aggregate, and the aggregate root of the backlog item aggregate is the backlog item entity. that entity holds other entities known as tasks. And we have some business rules around the concept of backlog item and task. Business rules that must be managed by transactions. The business rule that I'm referring to is a consistency rule that says when all tasks within a backlog item have 0 hours remaining, then we must transition the status of the backlog item to done. This must be consistent at the end of a transaction. Therefore, we put a transactional boundary or a consistency boundary around these concepts, and it's known as an aggregate. Aggregates produce facts. These facts are known as domain events. An example of a domain event, as you see in the lower right part of this slide, is backlog item committed. When a backlog item is committed to a sprint, the backlog item publishes a backlog item committed event. The product created event is another kind of domain event. Sprint scheduled, release scheduled, backlog item planned. These are other kinds of domain events that are published as facts out of certain aggregates. So when there are cross-aggregate dependencies, such as when a backlog item is committed to a sprint, we need to use reactive programming to bring the sprint aggregate into harmony with the backlog item aggregate, but this will occur in a separate transaction. How is this done? When the backlog item aggregate publishes the backlog item committed domain event, then the sprint will react to that domain event in a separate transaction. When the sprint is told to commit a backlog item to it, then a new committed backlog item is added to the sprint, and the sprint transaction is then committed. Thus, through eventual consistency, these two aggregates are eventually brought into harmony with each other through reactive programming, where the backlog item committed domain event causes an impact on another part of the model in due time. So one transaction saves the aggregate, date, and its event to a persistent store, and then the event is published such that it will have an impact on one or more bounded contexts. It may be our own bounded context or a remote bounded context. So how can you use these techniques to reduce time to market and improve the quality of your software, make it more flexible, scalable, and more tightly aligned with business goals? Well, I think you get the idea already that when you bring developers and domain experts together, you're investing in knowledge workers, in the knowledge of team members, building that feedback loop, and addressing the true software vision of the business. This is naturally going to reduce time to market. And if you look at my Domain-Driven Design Distilled book, Chapter 7 is a special chapter on acceleration and management tools that explains how you can use domain-driven design and accelerate the process of learning and crunching knowledge on a project. Software quality is enhanced because the business goals are addressed. We're not just focused on the data model, but we're focused on business process, business behavior, and this is all reflected in a core model through its ubiquitous language. Software is more scalable because bounded contexts are small and focused. You can scale bounded contexts as microservices, and these will help you to achieve greater success in team size, in focus on specific business goals, and help you to focus on other factors such as throughput and low latency. Now this is a part of the talk where Wes will take over, and so let's give control back to Jack to introduce him.
Thank you, Juan, for that. I think this is an opportune time to address a couple of the questions that came in before we move into Wes's segment of the webinar. So we have a couple of questions from Bhavan and from Greg. They both have to do with microservices, so I'm going to combine them. And the question is, can you talk about how microservices relate to domain-driven design concepts inside bounded contexts? Should microservices map to domain entities, domain services? Can you offer any guidance on how coarse or fine-grained microservices should be?
Sure. I think that bounded contexts meet with microservices very closely. If you've read Sam Newman's book on building microservices, you probably know then that Sam promotes bounded context as the first approach to developing microservices. So I think that it's a good first step in using microservices. If you look back at the slides that I was just showing you before, let's go back just a few slides. As you can see, there are very few entities or aggregates in each of these bounded contexts. Now, some like to think of a microservice as being the size of one entity. While that's possibly a good choice in some cases, I also find that concepts within a bounded context belong together because they're cohesive. They'll tend to form what you might even refer to as nanoservices within a bounded context, where they will collaborate together. And oftentimes, scalability factors will not push you beyond the size of the bounded context that you see here. So I think that bounded contexts, in general, at least as a first approach, make good bounded contexts. Now let me see the rest of the question. Should microservices map to domain entities? They might. There might be a reason why you want a microservice to be basically just one entity but that's probably if you have a very, very high scalability service level agreement for that specific entity. But I think most of the times, to be realistic, most of us don't have those kinds of requirements. And I think that a bounded context that is small, much smaller than a monolith, but also bigger than one entity is a very good size. Domain services, how do they fit into microservices? Domain services are part of the domain model. I don't see a domain service as being a microservice. So, and I think I've addressed the question about how coarse-grained or fine-grained, pardon me, a microservice should be. Hopefully I've answered that question. I think at least as a first pass, a bounded context that truly does adhere to a limited ubiquitous language is a good sized microservice. And Greg, I think maybe I answered your question too as well.
Yes, I think you did. Thank you for that. We'll come back to questions again at the end. So let's move on with Wes Williams, who's going to connect the dots for us and talk about how in-memory technology applies to these concepts. So take it away, Wes.
Yeah, thank you. I'm going to show a demo based upon these concepts. But first, for those who aren't familiar with Pivotal, Pivotal about 3 years ago was the largest startup in the history of Silicon Valley, and currently valued around $3 billion. We're focused on software. And our focus is to help enterprises scale with process open source software like Spring, Apache Geode, and we have a data engineering arm of which I'm a part so that we can bring you really cool demos like the one I'm about to show you. The demo that I'm about to show you has Reactor and domain-driven design concepts built in as one. And we're going to show a non-trivial demo, a Wall Street automated trading strategy. Several years ago, the Spring team and I built an algorithmic trading system based upon an execution management system. Those are bounded contexts, by the way. And Vaughn took this code and converted it, translated it to a domain-driven design style. That's the link right there in case you'd like to download that. And so what I've done in this demo is I've taken the Spring project Reactive Kafka, and I have a very high-speed price feed coming in using Reactive Kafka, and I'm using Pivotal GemFire as the eventing mechanism to do the reactive conversations between the bounded context. So let me get right into the demo, but first let me explain why I'm choosing these particular technologies. First, as far as Reactive Kafka, on my Macintosh that I'm running, a 4-core machine, I can publish high-speed streaming transactions into Pivotal GemFire at about 20,000 transactions per second and keep it transactionally safe. But using Reactive Kafka, I can boost that up to 1 million transactions per second on my little Mac. Why? How is that possible? Well, down in the lower right-hand corner, I highlight 2 primary reasons. One is the Kafka element of Reactive Kafka. It persists all transactions to disk. And what I can do is I can take advantage of that in case of failure and automatically replay failed transactions, which opens up where I can now asynchronously or reactively release those transactions into GemFire. So I can do about 1 million transactions per second using Reactive Kafka. I'm going to demonstrate that today. GemFire, why? Well, it's because GemFire and domain-driven design are a natural complement. How is that? Because with GemFire, if my application, I get data from my data store, or a region as it's called in GemFire, I'm getting the object. So my data is in the object or the aggregate, and I've got my business logic around the object. And so my business logic and data are co-located. It's an in-memory object grid. We don't have to do, as to the right of the screen, where I have an object, but I have to hop across the network to a non-object store like Redis or a relational database, and then stream that data, and then populate my object before I do anything. And so that's reason one I'm using GemFire. Another reason I'm using GemFire is because it has a natural eventing architecture for reactive programming. So starting from the upper left, I have an application, and when I persist that aggregate to my GemFire data store, let's say I want to save an order, I can save that order and transactionally commit the event that a buy order was created into the event store, and then GemFire naturally produces an update event that we can capture for our purposes. To the lower right, in the case of writing to a backend database, I can intercept the write event and write to a database or HDFS or an analytics database such as Greenplum. Or on the other hand, going to the upper left of our screen, I can launch what's called a listener, meaning I can listen for that update event, and then when that update event occurs, and it's an event that I'm interested in and I've registered, that event will be delivered a la reactive programming to my algorithmic order bounded context. And so that's another reason why we use GemFire for that. And the last reason is because I'm doing very high-speed calculations in memory. In this case, as I'm streaming price quotes in, I have an algorithmic trading system analyzing orders. But you have your company and you have your analytics. Wouldn't it be nice to respond to those analytics as soon as they're coming into your system before they go to a back-end data store where you analyze those transactions at that point? Catch it right when it's coming in. So if you're an airline, you could use this for flight scheduling, and some do. If you're target marketing, you can instantly analyze who's coming in and target their ads, or whatever your company's analytic is. You can use GemFire to operationalize that analytic. So that's why I'm using the technologies I am. But so that you can better understand the demo that I'm about to show, here are some features of that demo. I'm taking a high-speed stream of quotes, and I'm windowing over that stream and producing a 1-second price bar. More on what a price bar is in a moment. Secondly, for the analytic, I'm calculating the volume-weighted average price for each bar. More on what a volume-weighted average price is, but suffice to say for now, this is Wall Street's most commonly used algorithm for program trading. Third, you'll see me submit a buy order for 25,000 shares. And then our fourth you're going to see the algorithmic execution or order platform listening for that buy order. It's going to hear it, it's going to get it, and then it's going to be executing those 25,000 shares in 1,000 share slices. until it's filled. So for a total of 25 mini orders, all being submitted to the market. This is normal every day in Wall Street trading, all using domain-driven design and Reactor technology with an in-memory data grid. So before the demo, what is a price bar? Well, in my price feeder, I'm going to be emitting price quotes very, very rapidly in a pseudo-wave fashion. And a price bar captures all the prices or quotes that occurred within a 1-second window. And the first quote is the open, the last quote is the close, the highest quote that occurs and the lowest that occur are the high and the low. And we're keeping track of the volume of the trades or of the quotes as they come in. We're tracking the total volume. So you'll see these price bars displayed across the screen. There's a sample 5-second price bar for Apple that I snapshotted yesterday. And just briefly on the volume weighted average price to show it's a non-trivial analytic. It's the sum of the price times the volume of each bar divided by the sum of the volume over a period of time. When the volume weighted average price is below our target price, we're going to start trading. And then lastly, in our demo, when the request for the buy order is submitted into the event store, the algorithmic trading engine to the upper left is going to be listening for that order. And when it hears that a buy order has been requested, across these bounded contexts, we're reactively issuing that event. We're going to start trading. So, are we ready for trading? Let's open the market. And what I want to show you here is, before we start trading, the order I'm going to submit. This is a web-based API for GemFire that I can insert objects into GemFire. And I'm going to be inserting this trade into the GemFire region buy order request. We're going to submit a trade for 25,000 shares at $97 a share, and we're going to buy Pivotal. And that's a real steal at $97 a share. We're going to buy 25,000. All right, I'm not going to execute it now, but we'll execute it when trading starts. So this is what I'm doing is I'm opening the market for trading. The market is open for trading. We're trading at about $100 a share. I'm going to submit my order, and you see that the algorithmic order listener heard that there was a buy order placed. So as prices are streaming by, when we hit 96, our trading begins. If the price ticks above 96, trading stops, and there we're done. Well, that was fast. All right, what happened? Let's go back. The buy order was placed. That's when I pushed buy. The algorithmic order listener in the other bounded context was listening for a buy order place, and that submitted the trade for 25,000 shares. And the algorithmic engine submitted that algorithmic order Pivotal at 97. And so as trades are coming in for the VWAP price, we get down to where the order was triggered. And so when the VWAP price is below our target price, you can see that a domain event was sounded. A domain event occurred called the an algorithmic slice order, shares requested. And there were 1,000 shares requested. And the trading engine intercepted that domain event. And so we're communicating across the bounded context. Our trading continued. And of course, when it goes above 97, our trading stops momentarily and then continues on as more trades occur. Here we went above 97, so trading stopped, and then it started recurring again as we got below. Until the shares remaining were 0, at which point the domain event occurred called algorithmic order filled, similar to what Vaughn was showing as the hours remaining is 0. We published that order, and it went back to our client that reported your algorithmic order was filled. So all of this code is yours. That is the intersection of the Reactor Kafka that I use and Vaughn's trading platform written in domain-driven design style. The code that I'm showing you today, I'll release next week when we go through our Geode Summit, and will be available for question and answers on this very presentation. Because I want to give Vaughn the opportunity to go through what I've done and refine it. So in summary, I want to go back to my slides. What have we done? We've demonstrated how domain-driven design and Reactor are powerful best practices, and they're practical for the enterprise, as I've just shown you in the demo. GemFire is a natural complement to DDD and a natural complement to Reactor for the events that it transmits. Reactor Kafka, keep an eye on that project. I'm so amazed with the throughput that I'm getting from that and the usefulness. Thanks for Vaughn for modifying the trading system to DDD style. And Jag, I am done.
Okay, thank you, Wes. And thank you, Juan, for being busy on the Q&A window. I see that you answered a lot of questions that came in. So in terms of next steps, let me cover a couple of things where people can go for additional information. You've already heard from Vaughn about his books. They're broadly available. They're in circulation and can be easily found. So please go to your favorite bookstore to access his writing. He also offers workshops, and you can find out about his workshops at his site at iddworkshop.com, and he has both public and private workshops. The public workshops are in person, and he can, and also he has online training as well as part of his public workshop offering. He can also arrange for private workshops on the topic. So depending on how deep you want to go on the topic, there's various offerings that he has available to you. There is a tremendous amount of material on the Pivotal GemFire website related to the features and benefits of the product and use cases and examples of how our customers are using it. So definitely go there if you want to see more on the product. We also have a free intro to GemFire online course. And you don't really frantically have to be copying down this URL. You can just search for GemFire intro course, and you'll be able to find it. Today's demo is posted on GitHub, so those files are available to you as well. And you can also learn a lot about Apache Geode from the Geode website, which is geode.apache.org. We recently had a summit, a Geode summit, which involved presentations from several of our customers on their use cases and examples of how they were benefiting from the product, as well as experts from Pivotal to talk about the technology and its various capabilities. So you can definitely just search for Geode Summit, and you'll get a hit on all of those presentations. There is a upcoming community discussion with Vaughn, so thank you, Vaughn, for agreeing to come back and speak one more time. And that is on September 21st. If you go to the Apache site, you'll be able to join the community, and you'll be apprised of this presentation as well as various others that are coming up. We have a very active community of participants, so that you can actually get a lot of information by tapping into this community. So that's essentially it, and we're pretty much at the bottom of our hour here. Thank you very much for all of your assistance with this webinar and for addressing this exciting topic. I'm eager to continue this conversation as we move along, because obviously it's a topic of great interest. We had so many registrations; it was amazing, and the questions have been flowing in. So there's lots of opportunity for us to come back and talk about this some more. Thanks a lot, and see you next time.